Dear friends, I've left it far too long this time. It's got to be weeks since I released one, but I've just been so busy building machines. I haven't stopped, and because the videos take quite a long time to put together and everything, and even to film, I just haven't had time to do it. But this one takes us to finish the Epizoescope, that's right, and starting something else. I can't remember. I've got video files coming out of my ears. Hopefully you will enjoy it. Remember, if you like this sort of thing, click subscribe and the bell button. And as always, if you ever want any advice or help or support, if I can give it, I'm only too happy to. Just ask in the comments. Lovely. On with the show. Well, it's all connected up and working. I thought I'd try and work out how to run all this lot of stuff. And look, that's what I'm talking about. Isn't that lovely? Really does look so realistic. So we've got the different needs here. This needs about 3 volts. What else is there? The motor is about 1 volt, 1.2 volts. We've got the PIR sensor that needs that can run off the 12 volts because the screen runs off 12 volts. There's something else. Oh yes, of course. And the limelight effect needs about 3 volts as well. I've got 12 volts coming from the power supply because that's what the digital photo screen display runs off. So that's 12 volts coming in. I've remembered I had one of these little things. Amazing. That takes 12 volts with a little voltage regulator in the middle, takes it down to 3 volts. Then 3 volts can obviously directly run the flickering lamps and the candle, that's right. Then cunning plan, very basic, but using a row of diodes, because across each diode there's always about 0.7 voltage drop. So just running a series of them, how many is that? 1, 2, 3, 4, 5. 5.7, so something rather. 3.5, so it's taking, I don't know what it's doing. Anyway, it's taking it right down and it works. That's the main thing, down to about 1 volt. So that's great. Now the next thing I need to do, there's the back of the PIR sensor. So I'm going to run that off to 12 volts. I've just discovered that these little PIR sensors have a voltage regulator on, so they can run off 12 volts. So this whole unit is always going to be running from 12 volts. And then the PIR sensor, via a 555 timer, will then, when it sees movement, it will then switch 12 volts to the screen, which automatically, thankfully, starts up, finds files and starts displaying them. So that's good. And then after no movement is seen for say half an hour, it'll then switch the power off to everything. But keep watching. Oh how we laughed, one stupid thing that I've realised I've done. There's the PIR sensor. Just above it, can you see how the light's flickering over it? We've got this huge moving thing, the governor. How absolutely ridiculous. When I was working out where to put that, I just thought, oh yeah, that's a nice little place. It's not going to be effective or anything. Other than the fact it's got a huge thing that's, I think, could quite possibly keep setting it off. So once it's started, it never stops. What a fool I've been. The only thing I can think, if it is a problem, because it works on ambient temperature, I could always make some sort of little screen up here. Always a good opportunity to find some more bits to add so that it can't see that moving. Anyway, I'll have to wait and see what happens. I'm going to get on with a 555 timer now and just going to get all of this circuit built, mocked up on breadboard so I can just check that it's all working. Alright, now connected up the PIR sensor and I've got the multimeter in the middle. Let's see, because I've got my glasses on. What does it say? Nothing. So if I move, it goes to, yeah, 3, I've set it to no delay on the actual PIR sensor. It goes 3.3 volts, that's it. And as soon as I stop moving, it goes back to nothing. Now, unfortunately, it only does a maximum delay of 300 seconds, whatever that is. And obviously that's not enough. Unless you're racing around a room regularly pacing backwards and forwards, which I suppose you may be, it's going to keep switching off. That's why I need a 555 timer. But I meant to say, the great thing is, it's not being triggered by the balls on the governor. It only comes on when it sees a huge or lump of meat like me giving off heat wandering around. Balls! And I'm not talking about this sort. I was testing my lovely circuit last night, the hour-long delay circuit using the 555, and I could not get it to work reliably. It varied so much. And then I looked it up, and of course, and thank you for all of you who are going to point this out and probably have done in the comments, using huge capacitors like 1000 microfarad or smaller ones than that, but huge resistors like 20 mega ohms. There's so much leakage in a capacitor, electrolytic capacitor, and within the circuit itself that it just becomes completely unreliable. I've got an order for another barometric prognosticator 3. Here's the base, here are the blocks, and once that glue has dried I'm going to cut out some more nice twiddly bits, get them glued on, and while that's drying I'm going to sort out the Arduino Micro with a... oh yes, no, stop it! Time to employ an Arduino Micro. There's the Micro, and I've just checked it again. As you can see by the small flashing green LED, I've managed to speed it up, so I know it's still programmable. So, let's take all this to pieces and possibly unplug that, as it's making noises, and then start again. But this time, hopefully, with more success. Here's the machine being tested. Here's the super improved circuit board. How overcomplicated is it possible to make something? Nice big heatsink for the Darlington pair that switch the 12 volts. Then I noticed that this little 3.3 volt regulator was getting really hot. I know it's got a thermal protection inside, but why leave it when you can build a very strange looking heatsink out of a lump of copper and bits and pieces? So that's good. All the wires are connected and it works. Poor little Arduino Micro, just counting. Never mind. It was going to sit in the drawer unused, probably until it was thrown away, because I didn't think it worked. So it's got a new lease of life. So now I can screw that into there and get all the wires tidied away. I've got the screen in, which is lovely. More chance of it being wrecked and scratched outside the machine than actually in situ. I've got the circuit board fixed down and all the lovely wires just fixed in place. The interesting thing about this, because it's for someone else, not for me, I've had to think about things like this, because with the original one I didn't really worry about anything. It's just got the wires resting loosely, and then focus the circuit board, which I just built on a bit of variable stuffed in with the mains plug hanging off it and the power plug. And obviously that's not good enough, and also the fact you can put things in it and possibly hurt your hand, although I don't really see how on this spinning round. So things like that, but that was fine for me. And also, obviously, when I take this to steampunk events, it just stays the right way up, focus, in a box, and is protected. Whereas this one isn't. It's got to go in a box somehow. I'm still trying to quite figure out. I think I'm going to screw down the back, because that's really solid, like I did with the other machines, and then that should support everything. But obviously I don't know which way up this is going to go, so I've had to think about all this sort of stuff. To which end, look what I've just made. I've made a lovely panel, because that's going to sit in the bottom. I've got an extension lead for the USB, so he can plug in a USB stick with videos and things on it, so he doesn't have to fiddle around and poke about inside it. And I spent ages. It's just, you know, when you've got one of these projects and you've got some problem, something you need to do, nothing, you cannot work it out, but somewhere in the back of your mind you've got a niggling little feeling saying, there is a way, I know there is a way. And then I found the way. I could have just stuck a bit of wood over it, but then there wouldn't have been room for the power supply plug and the USB, and also it just nice lots of ventilation. I found I had some of this in the drawer, so bent it. And the idea is, I've made some extra little panels that sit in here. That's just going to sit flush, completely flush with the edge, to get rid of all the sharp bits. I've got a number of cuts as a result of the sharp bits, so they'll all be flush. That'll be lovely. Things you have to think about. Right, I'll get that together. what I'm doing at the moment is making another barometric prognosticator 3, and I've just got on to installing the read switch, which is going to allow the readings disc to let you know where it is. Let me show you. Inside this copper tube, 8mm annealed, there's a very thin strip of error board with a read switch on it. There we are. At a slight angle of the dangule. And because that's copper, non-ferrous, magnetism goes straight through it. Now the magnet, there's a sweet little magnet there, which I really mustn't lose because I haven't got another one. That fixes on the back of this big reading stick. The reason it looks like this gear, out of 10mm acrylic, is because I wanted to save plastic, and because this is going to be hidden behind the engraving for all the measurements, it didn't matter that I cut out all sorts of other exciting parts from it. So I tell you what, I haven't stopped. Here's The Godfather, which I'm watching the trilogy of, and here's the little drive housing. Oh, and I think I might have mentioned, there's the finished thing. I've got to work out how to fix this into a box so I can actually get that sent off. But here's progress on this machine so far. And I think, well, I've got all sorts of bits and pieces done, as you can see. I think I've got the painting problem with dust sorted out, because what I tried was having the filter going. That's the lovely dust filter in the workshop going all morning before I tried spraying it, to get rid of all the dust that's floating around in the air, and then to sit this on a box, because I thought with the pump, the blower sucking air out the back, it's going to be drawing air in. So all the crap and stuff that's floating around here, because I used to sit it on here, I thought that might be an issue, and it seems to have helped, because obviously crap being slightly heavier and cack isn't going to be floating up here. If it gets drawn over, it's going to just go along the surface, and I think that's worked really well. Touch wood. I won't say any more. There's the clocks around that I'm just spraying. I can't stop talking now I've started. And I've got all these lovely things that I've made up and am making up. And I've got the copious plans, because I've built many of these before, and it's so nice. And again, I'm making improvements. Every time I do these, I'm coming up with better ways of doing stuff. So that's almost enjoyable. Right, I will just get on with this, and I'll get back to you when I've got something else to show you. Because it takes so long videoing things that I get, it just takes too much time, and I've got so much to do now. I've just got to get on with it. So I will speak to you soon. That's what I mean. I've actually glued it in. I've lost it about 5 times because it's exactly the same colour. It just blends in. So I've finally glued it into my little holder on the back. So now I know. And the angle is that as this comes round, it then lines up perfectly. It's less likely to trigger it too soon or late. This copper, this 8mm copper, and these little 8mm copper fittings are an absolute joy, because I've got it all drawn out. So I've just built that bit, hoping it will actually be the right dimensions, because that's going to sit. That's right, look, that bit goes in the eel like that. Yep. Hopefully it'll all line up, and it's got to go over a little copper thing there. In fact, copper thing that looks exactly like that. Little saddle to hold it all in place. The reason I'm doing this bit now is because then I can fix the big dial on and check that it's working the read switch properly and all that. It's the gift that keeps on giving. I love building these machines. I've got a spinny thing, and I've got that copper fitted in, read switch under there, look. Oh, how lovely. There's a big bearing at the front and a little bearing at the back. That's lovely. Now I'm just putting together the drive assembly. Here's another top tip, which I'd never realised before. Fixing this on, this one still had the 6 little holes or 5 little holes that I'd push this onto the shaft and then drip super glue into the back, and it would fix it in place. But that was a right old pain, because despite ever carefully measure things, trying to get this, once it's all mounted, to align perfectly up and down with this gear, it was impossible. I kept gluing it in the wrong place. So last time I realised I could drill 2 3.3mm holes, one either side, from the outside at an angle to the centre, and tap them M4 for 2 grub screws. That's perfect. I've subsequently changed the drawing so it no longer has this thing, these holes around it. That's lovely. because now I can adjust this up and down on the new shaft. I'd come up with the most complicated way of making an acrylic shaft and laser cut shaft. In fact, I've got a piece of paper and it's got like a sort of comic strip covering the whole of one side, explaining how to make this wretched thing that's slowly got more and more complicated. Or you just put a piece of 12mm diameter brass in the lathe, in at about 5 minutes you've made a beautiful one. The barometric prognosticator 3 is going very well. As you can see, it's all coming together nicely. It's time for the flute. There's the bell, that's okay, but the flute now. And I was looking at my copious notes and things and trying to figure out what I need to do to link the bellows, which is those, which are from a cuckoo clock replacement parts that you can get, and the flute, which is that which I've cut off the wooden thing that it normally sits on. The bellows normally just glued onto the top, and that's what I used to do until I realised that with the barometric prognosticator the bellows weren't necessarily, or the motor wasn't necessarily lifting or closing, I can't remember which way around it used to work, the bellows. It was just too unreliable, so I had to come up with an alternative, which means I need to link the bellows to the flutes indirectly, a bit like this. So I dutifully got me CAD drawing and cut out all the salient parts, thinking, I don't know what all this is about, I'll figure it out when I've got something to herald in front of me. To cut a long story short, I didn't need all these funny little bits that I vaguely remembered using and had drawn. All I needed were these two bits, because I realised it came flooding back very slowly. Cut out on the laser cutter, and then I drilled out holes inside, and then drilled the 8mm holes connecting them, then sanded a mitre joint, because I remember realising that would seal the ends of the holes, and it works a treat. Look at this, it's beautiful, I told you, beautiful. And I've made a plunger. It's out of waxy polypropylene or something to reduce friction, and I've even got my strip of brass and I've sanded it down 45 degrees to make a little V shape. Let's see whether it works. Right, plunger. Brilliant! Now I know that all works perfectly. I can now go and spray that with the hideous silver paint that takes months to dry. The sooner I get it painted, the sooner it will be dry though, I think. Having taken the utmost care with hoovering and air filtering and everything else, I am absolutely thrilled to say that this gargantuan area of flute and swanee whistle and things has sprayed up perfectly. There's no bits of dust. I'm going to leave it under the air filter, held in place with a clamp, until it is well and truly dried, and then I'll drop it or scratch it or something. I'd also forgotten I put the battery in the clock last night. It's a radio control clock, so it uses the signal that's broadcast from a laboratory somewhere to actually set the time automatically, which is ever so clever. It means you don't have to keep, well, you don't theoretically ever have to go around the back to adjust the hours back or forwards in the summertime or whatever else. That's nice. I'm just hoping that it works in South Korea, which is the destination for this particular barometric prognosticator. Luckily, if it doesn't, there are buttons on the back of the clock movement that allow you to adjust it manually. Very clever. Another day, following another sleepless night thinking about this. So I keep thinking, oh no, there's a better way of doing it. It's all well and good if you can carry it the right way up, but knowing how some couriers throw these things around and really couldn't give a damn, to the extent where I'm not even going to risk putting a fragile sign on it, because I know, experience with FedEx at least, and I've heard from lots of American customers that they are awful. They employ people who I think specifically are there to look for fragile signs and then to take the necessary disruptive action. Oop, there's the doorbell. It was the nice postman who was delivering this from the mesh company. I wonder what I ordered from them. They're still around, as aren't many companies that I used when I started off about 6 or 7 years ago. They sell every conceivable type of mesh. An incredible amount of mesh. And I've nearly run out of this. I haven't got enough to make any more, so I thought I'd think ahead. That's what they've sent me. That's exciting. Now, you'll know that I do love an engineering drawing. I think they're amazing. Following the standards, the international standards, theoretically properly, you can read any engineering drawing done by any engineer in the whole world. It's just fantastic. It's so clear, concise and lovely. And I remember learning it, first of all, when I was at school, TD lessons, technical drawing lessons. And then again doing it at Central School of Art and Design when studying industrial design and engineering. That's right. And in those days we all had an AO drawing board with parallel motion, and that was it. And pencils and huge sheets of tracing paper. Amazing. Now that's why I'm so appreciative of CAD, my little simple CAD software. Because I still appreciate the amazingness of just being able to pick up bits, edit bits, move bits, copy bits. Because before you couldn't do any of that. If you made a mistake, you'd have to get a little erasing, they were called erasing guides, Windows things. Oh, everything's gone from my head today. They were a little stainless steel sheet with little slots and circles, and you'd lay it over the line or whatever that you'd needed to erase, and then you'd erase through it, and it would allow you just to get rid of the bit you didn't want. But enough of wittering. Look, ooh, working with brass again. I need to make the 4 supports. Here we are, 1, 2, 3, 4. They're going to hold the bearings, which are 1, 2, 3, 4. That are going to allow this swanny whistle thing to slide backwards and forwards. That's lovely. And as I've mentioned before, I won't go into all this in too much detail because I've mentioned it lots of times before. Tapped 4mm M4 at the bottom to screw through the hole, but at the top M5 because that's the hole in the bearings. Offset. A cunning plan. I'm so pleased that I realised I could do this because it means I can adjust, and nothing's ever perfect, and this gives me enough adjustment to allow this the brass bar to slide backwards and forwards. So that's nice. I've also cut out the bits for the Scotch yoke. A Scotch yoke is a type of mechanism, and I'm so pleased with this. This bar is 2.5mm thick, and by engraving, after lots of experimentation, a little rebate in that bit that sits at the back, then you've got the middle bit with the 2 slots in, then you've got the front bit. It makes a beautiful sandwich into which the brass bar just slots perfectly into that hole, and then I can screw it through. Isn't that lovely, with the nuts captive in the back? I'm so pleased with that design. Now you do know how much I love jigs. I've got 2 drawers of them. All sorts of jobs they do, jobs that would be otherwise really impossible, and a jig makes them into an absolute joy. I will go through these. I'm not going to unwrap them all now or unpack them. I'll go and find the right one. I did. I've just found it. It was hiding amongst the others. There we are, the 2 bearings. I'll undust it and then try and get it all lined up. It's glued together. You can hear the original in the kitchen doing its thing. And then this brass rod, look at that, isn't that lovely? I'm so pleased with that. And I know the bearings will fit up and down in here because they did on the jig. So that's lovely. I'll get this painted up. Look! I managed to get that on without scratching it with the aid of my lovely cotton glove. That is really good. That tube, the plastic tube spray painted, is 21mm diameter. These Munson rings are for 22mm pipe. So I've glued a little bit of rubber in the back rather, and I've realised not to tighten this because one of the first ones I made, I tightened these really tightly, and over about 2 years it slowly crushed the tube, which is acrylic, so that the plunger wouldn't go in and out. So, top tip, just tighten them so it just touches, a little drop of super glue on each screw to hold it in place. But this, oh, oops, I pulled it right up. Look at that. And the way the bearings turn and catch the light, isn't that lovely? And it's, oh, it's just, it's a joy. It doesn't take any force at all. So there's the crank with its bearing on, 13mm bearing, and that's nearly dry. I'm going to go and have some lunch, and then we'll get this assembled. Ooh, oh, Cantona. Oh, I love it. I'm just about to take the dog for a walk, and I just glanced over. I've got all this fixed down. I've just glued on the bellows. Oh, it's just, I just caught a glimpse of it, and it just, oh, it's lovely. Even though CSM is Sen, I do love all this Victorian style engineering, all the colours and the metallic and the wood and this and that. Oh, it's lovely. And I do love the fact that wherever you look in these machines, you get a lovely little vista. I don't want to sound too pretentious. Also got the little sprongler made up that holds the chain pulley, and the chain is now fixed onto the motor. So it's all coming along nicely. I've got it all strung up. It's got the spring here so that the motor doesn't jam when it finishes pulling. It's got a little thing here to stop it over winding. It's got a stop here so that the bellows don't get pulled too far. Ooh, who would have thought playing bellows with a little motor would be so complicated? Now let's talk lamps. Obviously there's a lamp to illuminate it that sits here. I've been making them, another top tip for you, I've been making them from these confetti holders, balloon weights that you can get on eBay all over the place actually. They come in two halves that clip together, and you can put something in it like confetti, and it's got a hook on the top that you can tie one of those helium balloons on. Again, you know, you think, I spent ages thinking there's got to be a product that's a semicircle made of plastic that I can use for the lamp housing. Because if you can buy them from model shops and things like that, but they cost a fortune. So pleased that I realised you could get these. Now, I've used up all the ones that had the rim on the inside that clip together. So this is the first time, as obviously I've got the same number of these ones that are on the outside. So I've made a new ring that I've just glued on, and I'll see how that works. Hopefully it'll work. It's a shame to waste all the other halves. And here's the back. How lovely. I mean, done all the mechanics and building and bits and pieces. It's now time to do all the wiring and things. I've got the original circuit diagram, thankfully, sort of connecting diagram. In those days, because this was when I built the first one, I only had red, black, blue and green wires, hence the unimaginative colour scheme. Got far more colours now, look, lots of pretty colours. I've got everything I need set up except the barometric pressure sensor, which is going to go there. There's the wonderful little 433 megahertz radio receiver. Isn't that incredible? That's short aerial, that's what is it, 17.3 centimetres long, and all the data just gets sent down a wire which you can connect straight to your lovely Arduino. Amazing. I'll get on and start wiring all these lovely pieces of wire up. And there we have it, sometime later. What a joy! I always put all the red, all the plus fives and all the 0 volts together first of all, and it's so enjoyable just going around and connecting up all the other wires and bringing them all back to the lovely Arduino. The packaging box for the Epizoescope just gets more and more complicated. It's almost as complicated as the thing itself. I'm now reinforcing the huge box that I made to get it to fit perfectly with plywood. I'm just gluing a piece along the top. It is so involved, it's ridiculous. The thing is, if I knew it would be transported all the way there standing upright or on its back, wouldn't be a problem, because I transport mine around in a cardboard box standing upright, no problem. But the thing is, I don't know what it's going to go through on its way to the United States of America. Heaven only knows. It could be thrown around, it could be sat upside down, it left hanging, I don't know. So I've got to try and ensure that it arrives in one piece. Oh dear friends, it's so exciting. I've just uploaded the sketch, made a few minor adjustments to sort of tune the motors and stuff for the cuckoos, and switched on. Obviously it just sits there and waits. It plays the national anthem once to let you know that it's sort of working, and it sits and waits for a signal from the wireless weather monitor, which sounds simple, but it is so complicated. sort of pacing the streets and stuff. I'm almost sort of stuttering. Pacing the streets, and I thought, just in case, because of where we're situated in here relative to where the wireless centre is, and because I was getting impatient, I thought I'd bring it inside. So I sat it there, waited a couple of minutes, and then it played the national anthem again, and this flickering lamp's come on. I've just been watching this and thinking about how many complicated things have to go right for this to work properly. I'm thrilled with the wheel and the motor. In fact, if I press reset on the back, I will show you. Where is it? It's on, there we are. There's a reset button. So when you first switch it on, it fades up. I mean, I was thinking that's something for a start. Logarithmically fading of the LED. That's nice. Then this turns round until the read switch lines up with a magnet. Again, that might not be working, but it is. Yeah, and then there we are. So I now know the motor is going the right way around because it's playing the right pitches and things. So that's good. And I've got this tuned a little bit with the motor, as I say. And then sitting there, twiddling my thumbs, waiting. The power light's flickering. I did manage to find a huge blob of that amazing sort of quantum crap, it must be, quantum cack. Because there was nothing in here when I sealed it up. I hoovered it, I cleaned it, put it all, glued it all in, nothing. Switch it on today and there's a huge speck, the size of a beetle sitting inside this lens. Amazing, I tells you. Luckily it hadn't glued that well, so I managed to pull it off and there, look. Oh, that's what we're talking about. Oh, that means so much, because there is so much going on behind the scenes, and now it can tell me it's very dry, because it's now starting to get readings from that the monitor, and oh, I'm so pleased. So now things I've got to test, I've got to see, because at the moment it's just running on some sort of arbitrary values that I've filled the arrays up with inside, so I need to see whether it starts predicting it, because I can tell you it isn't very dry. And I've got to see whether it goes to sleep, whether the PIR sensor works, whether it fades down. I haven't even tried the switch or the bell yet. Ooh. Let's see, at the moment it's displaying pressure. Let's try it. Display temperature, so that's 3. 1, 2, 3. Oh, that. So this should be temperature. And again, it's got to do so many things. Oh. I was getting confused with a different machine, the chronological engine. It works, but I don't know what I'm doing. I'm so busy making so many of these things, I'm getting confused as to how they even work. Yes, that's it. Then it rings 3 times to play the last 8 hours of temperature, that's right. Oh, thank goodness for that. Fantastic. Voila. I'll leave that and beep 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 beep, get on with this ever increasingly complicated box. You know, you lie awake at night thinking, oh, but what happens if they drop it there or throw it there or sit it there? There's another new piece of wood to reinforce that side. I'm almost ready. I think I may even drill the holes that I marked out here. I think I might even put it into the box.